Fehling's solution is a chemical reagent used to distinguish between reducing and non-reducing sugars. It yields a positive result for aldose monosaccharides due to their oxidizable aldehyde group and also for ketose monosaccharides as they are converted to aldoses in the presence of the base in the reagent. To prepare Fehling's reagent, we need potassium hydroxide, copper sulfate, and potassium sodium tartrate. The reagent is composed of two solutions, A and B. Solution A is made by dissolving 7 grams of copper sulfate pentahydrate in 100 milliliters of water. For solution B, we dissolve 35 grams of potassium sodium tartrate and 10 grams of potassium hydroxide in 100 milliliters of water. Stirring these solutions results in 2 clear liquids. Fehling's reagent is prepared just before use by mixing equal volumes of solutions A and B, resulting in the formation of a dark blue tartrate complex of copper. The coordination chemistry involved is complex, with various species having different metal-to-ligand ratios. To conduct the experiment, we have 3 solutions to test. From left to right, distilled water as a control, sucrose, a non-reducing sugar, and glucose, a reducing sugar. We add 10 milliliters of Fehling's reagent to each solution. The solutions are then heated on a hot plate, and we observe the color changes. The tartratocuprate complex oxidizes the aldehyde to a carboxylate anion, reducing the cupric ions in the complex to cuprous ions. This results in the precipitation of red copper 1 oxide, indicating a positive result for reducing sugars.